Hi, everybody. I am here to give another solution. Requested on the forum was exercise 10 from section 4.7 from the WebAssign. So let's look at it. I got a screenshot here. There's a second part with some graphs, but I'll leave that to you to think about. So the question is here. It says a model rocket is fired vertically upward from rest. Its acceleration for the first 3 seconds is given. It's 66t. The acceleration of t is 66 times t, at which time the fuel is exhausted and it becomes a freely falling body. So that means the only force is due to gravity. So there's only a constant acceleration due to gravity. 15 seconds later, the rocket's parachute opens and the downward velocity slows linearly to negative 23 feet per second in 5 seconds. The rocket then floats to the ground at that rate. And we're asked then to determine the position function and the velocity function as a function of t. Right. So again, the red numbers here might be different for each of your solutions, each of your problems. So that 66 might be different, the 15 seconds may be different. But the model for how to approach this should be the same. And you'll notice here, I'm actually using the instructor's guide. So I've got the answers right there. I'm not just giving you the answers though. Let's discuss them and see where they come from. All right. So in general, we know that there's a relationship between position, which we're calling S of t, and velocity, v of t, and the acceleration. Namely, v of t is equal to s prime, the rate of change of the position. That's just velocity. That's the speed at which an object is moving, and the sign is telling you that an upward speed or a downward speed. That's velocity. And then the acceleration is equal to the rate of change of the velocity. So the acceleration is the derivative of the velocity, which then of course means that the acceleration is the second derivative of the position. Right, so that's all well and good. If we knew the position, then we could work out v of t and a of t by taking derivatives. But we want to go the other way. We have the acceleration, and we want to figure out the velocity, and we want to figure out the positions. So I guess that means the antiderivative. Or we now know it as the indefinite integral. So that's going to be our line of attack. Our strategy is to take our functions for acceleration and use indefinite integrals to figure out the velocity and the position functions. And that plus c that everyone makes such a fuss about is going to turn out to be crucially important. So let's start from the beginning. What we know is that a model rocket is fired vertically upward from rest. So it starts off with, it's on the ground, so the position is 0, and its velocity is 0 because it's at rest, and then it accelerates for 3 seconds at a of t equals 66t. So if on the interval from 0 to 3, that's t equals 0 up to t equals 3, we know that the acceleration is equal to 66t. So this means that the velocity, well, we know the relationship between velocity and acceleration. The velocity should be the antiderivative, or the indefinite integral of that acceleration. So it's the integral of 66t dt, which should be, I guess there's going to be a t squared, and then a 33 here. We'll make it so that the derivative was 66t. And we have an additive constant. So far, so good. Well, remember, we know that the velocity at the original time 0, when we start, that should be 0, which means that if our velocity is this function, 33t squared plus c, then that's 33 times 0 squared plus a constant. That implies that our constant must be 0. So now we can be much more explicit. V of t is not just 33t squared plus some constant, it's 33t squared plus the 0 constant. So there's our velocity, and that matches the WebAssign solution right there. So now we know on the interval from 0 to 3, the velocity is 33 t squared. All right, I'm going to leave that here for now, although we may have to clear it in a little bit. Well, now we want to figure out on the next interval. So what do we know? After those 3 seconds, the fuel is exhausted and it becomes a freely falling body. Well, reading in the textbook or knowing a little bit of knowledge of physics or even looking things up online, we'll find that the acceleration due to gravity is, well, it's 9.8 meters per second squared. But I guess our units are feet and seconds. So in feet and seconds, the acceleration is about negative 32 feet per second squared, right? That's a constant acceleration. If you think about it, the force of gravity is constant. So the acceleration due to gravity is constant, which means that, well, on our interval now, it's from 3 seconds, and we know that this happens, something else changes 15 seconds later. So I guess we're looking from 3 up to 3 plus 15. Let me make that a little bit larger. On the interval from 3 up to 3 plus 15, our acceleration is constant, negative 32. So our velocity is just the integral, the indefinite integral of negative 32 dt, which is just minus 32t, but again, we have an additive constant. So now we have to think about how the velocities connect up. Velocity shouldn't change instantaneously. Acceleration might change fairly instantaneously because forces are applied and forces stop and different things happen, but the velocity due to that acceleration should change in a continuous way, which means that the velocity at 3, according to the function we're going to use here, should agree with the velocity at t equals 3 we had up there. Well, we knew that on the interval from 0 to 3, this was our velocity, 33 times t squared. So that means that v of 3, the velocity when t was 3 seconds, should be 33 times 3 squared. Now I'm going to use a calculator to calculate these because the numbers are going to get a little unwieldy, but 33 times 9, that should be 297. Well, that means that our velocity, the thing we've just calculated, up to some additive constant, should agree with that number when t is equal to 3. So v of 3 is supposed to be negative 32 times 3 plus an additive constant, but it's also supposed to equal 297 since that's what the velocity was at 3 seconds according to our previous formula. So I guess we could calculate c from here. Again, I'll use the calculator. I'm going to take 297 and I'm going to add to it 32 times 3. And I will find that c is supposed to be 393. So now we can update with a more accurate version of our velocity function. It's minus 32t instead of some arbitrary or undetermined constant. The constant is 393. Well, that's not quite what the WebAssign solution has written. But if you multiply that out, if you distribute the negative 32, negative 32t, okay, that looks right. And then on the other hand, if you distribute the negative 32 to the negative 3 and add that to 297, you should find 393. So they're doing it in a slightly different way. They're organizing it slightly differently. But I think it's a good way to think about it in terms of figuring out what that additive constant will have to be. And WebAssign accepts these answers because these are correct. It's just a compactified version of the answer that they have. So let me go ahead and write that up here so that we have it. This is the same as v of t equals negative 32t plus 393. So far, so good, hopefully. Okay, so that's gotten us up to 18 seconds. That's 15 seconds after 3 seconds. So now what happens? Well, 15 seconds later, the rocket's parachute opens and the downward velocity slows linearly to negative 23 feet per second in 5 seconds. All right, so they're really not telling us exactly what the acceleration is here. They're giving us some information about how the acceleration changes, but we're told that it changes linearly and we can figure out functions for lines. So that shouldn't be so bad. Let's think about this. Well, we know already now what the velocity is supposed to be at 18 seconds. If our velocity on the previous interval was here, was this minus 32t plus 393, then I guess velocity at 18 seconds is supposed to be minus 32 times 18 plus 393. Let's see what that is. 393 minus 32 times 18. That is minus 183. On the other hand, we know that over the course of 5 seconds, the velocity changes linearly and becomes minus 23. So in other words, v of, let's see, 18 plus 5, that's 23, that is equal to negative 23. That is the velocity after 5 seconds. So, okay, we've got a line. We've got a line with t value 18 and v value negative 183, and another point where t is equal to 23 and v is equal to negative 23. So let's figure out the slope. The slope is, I guess I'll write it as minus 23 minus negative 183. That's the rise, divided by the run. That will be our 18 plus 5 is 23 minus 18. Let's go ahead and work that out. We've got minus 23 plus 183 is 160 in the numerator. 23 minus 18 is 5. And, well, 160 divided by 5 is 32. So there's the slope of our line. Or maybe I'll call it M. It's a familiar name for a slope. Well, then we know one of the points. Let's pick, say, this one, 18, negative 183. So I'll write down the point slope form, but with v's and t's in place of y's and x's. So v minus negative 183 is equal to our slope, m, 32, times t minus our input t value, 18. So that means that v as a function of t, well, that's going to be 32t. We'll take 32 times negative 18. And then we'll also move the 183 over. That will be positive on the left, so it'll be negative on the right. This should be minus 759. So there now is the velocity on the interval. Let's clarify this. This is on the interval from 18 to, well, 5 seconds later. So 23. All right, let's just quickly double check that that makes sense. We look at the solution we have up here. That was 32 times t minus 18 minus 183. Oh, that's exactly the calculation we just did to get this nice velocity as a single linear function. So I'll go ahead and write that in. V of t is in fact 32 times t minus 759, or you could leave it in that form, 32 times t minus 18, all minus 183. Finally, on the last interval, what we know is that once the parachute has opened and the velocity has slowed linearly over 5 seconds, to a specific velocity, negative 23 feet per second. Then the rocket floats to the ground at that rate. Well, what is that rate? That rate is negative 23 feet per second. So I guess the velocity is just the constant negative 23 for the remainder of time. Really, this is time until the rocket hits the ground. There's a little bit of non-reality to saying t is anything greater than 23. But since we don't know exactly when the rocket hits the ground, it could be sometime quite after 23. We'll just leave it as t greater than 23. That should be reasonable. Great, so that gives us all of our velocities. From then, well, what should we do to figure out the positions? We said that the velocity was the derivative of the position, so the position should be the antiderivative of the velocities, so we should be able to do the same thing. Clear all of these calculations. Again, to go now from velocities to positions, s of t's, we're going to use the indefinite integral, or the antiderivative. So for example, we know that on the interval from 0 to 3, well, we worked out our velocity. It was 33t squared, which I guess means that our position is the integral of 33t squared dt, or t cubed with an 11 in front, plus some additive constant. Well, once again, we can use the fact that we started on the ground, so the position at time 0 is equal to 0, which implies that c must be 0, because 11 times 0 plus c equals 0 tells you that c must be 0. Thus, s of t really is just 11t cubed, as stated here. So without going into all of the calculations, the rest will follow the same kind of pattern. In order to get the position on the interval from 3 to 18, we should take the velocity on that interval, integrate it to get a position function up to some additive constant, and then use the fact that we know the position from the previous interval at the beginning of the new interval to figure out what that additive constant would have to be in order to have a continuous function of position. So the numbers get a little bit funkier, but this is homework. You've got some time to work it out. You're free to use a calculator or software. So I'll leave the remainder of the calculation to you guys to work out. Hopefully this was helpful, and I'm happy to do more videos if you guys are interested in watching them. Thanks so much. Have a great weekend, guys.